In this video, we are going to see what will be the depth of neutral axis in a singly reinforced rectangular beam. Here we have a singly reinforced beam which is loaded with a uniformly distributed load of intensity W kN per meter, and after the load is applied there will be some kind of deformation in the beam. Here you can see this line which is known as the neutral axis. Neutral axis means the line or the axis where the value of strain and stress is equal to 0. So after the load is applied, the beam will go into certain deformation, and here you can see it is now bent into a curve shape. Here this portion is also bent and this portion is also bent, and here you can see the neutral axis is also bent in the similar manner. The portion above the neutral axis is known as the compression zone, and the portion below the neutral axis is known as the tension zone, and the portion in the axis line or at the neutral axis, the stress and strain is again equal to 0. And now let us see some of the figures. Like, suppose this is the section of a singly reinforced beam with 3 bars here, and this is the neutral axis, this is the compression zone, and this is the tension zone. The width of this beam is equal to capital B, and the effective depth means the distance between the outermost fiber of this compression zone to the centroid of this rod. This is equal to small d. And after the load has been applied, certain strain is created here. So to show that strain, now I will draw a strain diagram. Okay, now the maximum strain in the outermost concrete in the compression zone will be equal to 0.0035. It is given by our IS code IS 456-2000. And at some point we have the stress equal to 0.002, strain equal to 0.002, and the strain in the tensile zone or the strain in the reinforcement is equal to 0.87 Fy divided by ES plus 0.002. Now this 0.002 term is added for the long term, which is known as the creep. This is for the long term deformation. And now let us see the stress diagram. To resist the strain, certain stress is also created in our section. So the stress is parabolic up to 0.002 strain, and then it has a constant value, and then it will make a rectangle here. The maximum stress in the concrete will be equal to 0.446 FCK. This is the tensile force, this is the compressive force. The tensile force will be equal to 0.87 Fy AST, and the compressive force, this is equal to T, and the compressive force C is equal to 0.36 FCK B into XU. Now this compressive force will act at a distance 0.42 XU from the topmost concrete fiber. So this is our section, this is the strain diagram, and this is the stress diagram. Here I can write. Okay, now we need to find the value of depth of neutral axis. Here the depth of neutral axis is this one, which is denoted by XU. Okay, now to find the depth of the neutral axis, what we will do is we will take the equilibrium condition of the beam, and the beam will be in equilibrium when the net force is equal to 0. Here in the stress diagram we can see we have two forces, the compressive force and the tensile force. So for the beam to be in equilibrium, C should be equal to T. Okay, so the value of C is 0.36 FCK B into XU, and the value of T is 0.87 FY AST. Now from here what we can see, XU will be equal to 0.87 FY AST, which is divided by now 0.36 FCK B. Okay, so this is the value of depth of neutral axis, but in our code the formula is given in the form XU by D. Here the term XU is divided by D, so we will divide the term in the right hand side also by D. So this will be equal to XU by D equals to 0.87 FY AST divided by 0.36 FCK into B into D. So while analyzing the singly reinforced beam, what we can do, we can find the depth of neutral axis in this manner. And now if you want to find the limiting depth of neutral axis, then from clause 38.1 of IS 456 2000, in the note the value of XU max is also given. It is given as for FE 250, 415 and 500, the value of XU max by D. So for 250, FE 250, the value of XU max by D is equal to 0.53. For FE 415, the value of XU max by D is equal to 0.48, and for FE 500, the value of XU max by D is equal to 0.46. So using this XU by D and XU max by D, you can find out what type of section it is. Either it is under reinforced or the balanced or the over reinforced section. I hope you liked the video. If you really liked it, please hit the like button and do not forget to subscribe my YouTube channel and also share with your friends. Thanks for watching.